Okay, so this is going to be a review or some backup, some help, some notes for 11.5 and 2.6. 11.5 and 2.6. These are a combined section where we're working on using regressions, but we're going to use the data and we're going to make our own decision based on the data of what the best type of regression is. So in the past we've done quadratic regressions and cubics. We've even done some quartic regression. We did some exponential regression, and we can also do linear. It's not much. It's actually simpler. You need less points. But what we're going to do is we're going to try to use the calculator as a tool to be able to plot the data effectively, and then make our own decision about, do we think it's linear, exponential, or quadratic? Those are going to be our three types. And so just over here on the side, a linear graph should look like a bunch of dotted dots that tend in the same direction. And if we see that, we're going to try to represent it by linear. In quadratic, we remember our quadratics look like U-shapes. Now these can also be upside down, but if you're seeing something like that, the assumption is that there's a quadratic model that may not fit perfectly. So there's going to be some points that don't go through, that the graph doesn't quite go through, but generally speaking it should be a good fit. And the last type we're going to talk about is exponential. If you're looking at an exponential data plot, you'd be looking at something like this, where there's just one turn and it turns pretty aggressively upward. So you can see that graph, it starts out very flat. Now if this graph started to trend back upward, I would think it's quadratic, but there's going to be some sort of an exponential graph that again may not be perfect, but should go through the basic trend of those points. So that's what we're going to do, is we're actually going to use the calculator. We're not going to do a ton of algebraic work on the side, but we are going to look at the calculator and try to run some stuff through here. This is all going to be in the stat button, so we're going to do a ton of regressions is what we're going to do. But first we need to figure out which type. The truth is, most of the time data doesn't perfectly fit one type or the other. So we're looking for what seems like a reasonable fit. To do that, we want to look at the graph. Now I could build my own XY axis and graph this, but it's not going to be a very good approximation. So it'd be way better to have the calculator or some other type of technology help me out. So in my L1 I'm going to put all of my x's. 0, 1, 2, 3, 4, 5, and 6, and 7. Alright. Then in my L2 I'm going to go ahead and put all of my y values. Excuse my hand, but my y values are 14, 537. Oops, I lost one. 14, 537. There we go. And then 15, 605. And then 16, 552. And 17, 229. Now I'm doing these as the examples in the textbook, so you won't find these in the problem set. They're in the examples earlier in the book, but they're just the exact same as what you're doing the whole assignment through. So that puts me at 18, 340, and then 19, 307, 20, 106, and last but not least is 21, 183. Now I'd like to see what this looks like in the calculator. And so what I need to do is I need to actually go up here to where it says stat plot. To do that I'm going to have to press second and y equals. And I want to turn on my stat plot. So I'm going to press enter and press enter again. Now what's going to happen is it's going to take my L1 and my L2 and plot them as points. The only problem is there's zero chance that my calculator is going to view the 21,000. So I need to change my window while I'm doing this. So I'm going to press window. I'm going to look at my lowest x was 0. So I'll say -2. I want to include all of my points, so I'm going to go to 10. 10 is bigger than my 7, so that seems okay. Counting by ones makes sense, but my lowest y value was this 14,537, so I'm going to say 14,000. My biggest y value, my y max, was 21,183, so let's go 22,000. And let's count by, say, 1,000. And it just needs to be a number that seems reasonable. Now when I go to the graph, you can see the data. Now in terms of our three options, I would have to say that this looks the most like a straight line out of the group. So we're going to look at linear. Because I think it's linear, I'm going to go ahead and hit Stat, slide over to Calc, and I'm going to choose, linear regression. And I'm going to come down. Now right here, this is not necessary for your homework, but I want to show you something along the way. So it says store the regression equation. There's a button right down here. It says VARs. It stands for variables. I'm going to go in here. I want to pick Y variables. It's a function, and I'm going to pick Y1. So what this is going to do is it's going to take my equation and store it in Y1 in my Y equals. So now when I come down and press enter, I get this equation. So over here, for this one, I'm going to want to write Y equals 933x plus 14,591. There's a pretty good approximation of my equation. Now when I actually go back to the graph, this should graph the line with the data. Now we can see the data doesn't perfectly sit on the line, but the line does an extremely good representation of the data in general. And that's really what we're after. You're going to do this over and over again, just looking at different varieties. I want to show you one other thing that we can change in the calculator. And that's in something in the mode. On these newer calculators, you can change a setting in the mode to do something called Stat Diagnostics. And when I turn this on, it's going to give me some more information about my linear regression. We're looking specifically at this R value. You see that it's 0.999. That means this is a 99.9% accurate equation. It's not perfect, but it is so darn close to perfect. A perfect R value would be 1. And so we are sitting really close to an exact equation. Obviously, I rounded it when I wrote the equation, so I created a little bit more error. But we are darn close. Let's do it again, but let's do it for another data set, another variety. So we're going to edit our data. On our second equation, we're going to go 0, 10, 20, 30, 40, and 50, and 60. And we're going to delete that individual entry. I won't need this last one. Okay, and then I'm going to come back up, and it's going to be 100, 75, 50, 35, 28, 20, and 15. So I'm just taking that next data set. I'm going to go ahead and I'm going to go look at this. I don't know what type it is yet, but I do want to change my window. Now I already turned the stat plot on. That's going to be on until I go back and make some change to it. So that's going to be there. So be careful. You do have to turn it on the first time you use it on the calculator, and then you're going to want to turn it off afterwards, because if you're doing something else and that stat plot's on, it can cause you a little bit of grief. But my lowest x value is 0. My highest is 60. So I'm going to go, say, from 0 or from -2 to, let's say, 65. Counting by, say, 5s. So maybe I'll come up here and make this -5. It doesn't actually matter. It's just a, I like that better. My lowest y value was 15, so let's go from 10. Highest value is 100, so let's go 110. And let's count that by, we'll count by 5s again. Now if I go to the graph, okay, this is not a straight line. There is some curvature to it, but it doesn't seem to be returning. In fact, it goes from pretty steep climb to where it is becoming shallower and shallower, more flattened out. That reminds me a lot of this exponential graph down here. I can see that on one side it's pretty vertical, and on the other side it's pretty flat. It looks like this is a reversal of that, but it still looks like that's the type of pattern. So I'm going to go ahead and go to Stat, Calc, and I'm going to find my exponential regression, which is option 0. Here again, I'm going to choose to store it in my y variables. It's a function, it's y1. Alright. Now I still have that stat wizard on. So notice it's going to give me an R value. Negative just meaning that it's downward trending, but it's at 0.998. This is a pretty darn good fit. Looking at my equation, y should equal 98, we'll say 0.2 times 0.969 to the x. Remember, exponential functions have that format. And those are always given at the top of our regression. So really, really close fit. Let's look at the graph just because we can. And sure enough, that is a darn good fit of my data. A straight line would clearly miss the curve to the data and be a bad representation. Now, this is dying off and flattening out. Okay, so that's really important for us to understand. Let's go ahead and look at our last equation set, our last set of data. So we're going to stat, and we're going to edit the data again. This time our x's, I'm going to start at 15, and then 20, 25, 30, 35, 40, 45, 50, 55, 60, and 65. Now you might be asking, do I have to put in all the data? Well, the truth is that every time you remove data from the set, you get a less accurate answer, a less accurate equation. So my y values here, if I start back there, is 22.3 to start. And then I'm going to go to 25.5, 27.5, 29, 28.8, 30, 29.9, whoops. Got to get that data in accurately. 30.2, 30.4, 28.8, and 27.4. Now if you haven't guessed, yeah, this is going to come out quadratic looking, but let's go through the steps again. Window, I need to change them. X min was 15, so I can say from 10 up to, I went up to 65, so let's go to 70. That should take care of my x's. Counting by 5 still makes sense. Y value, my lowest y value was 22, so let's say 15 up to, the highest y value was like 30.4, so let's go for 35. And I could probably count by ones. That's not a very big gap, but if you want to count by twos or fives, that's fine too. We're going to go ahead and got to clear this. There we go. We're going to graph. That, it does have like a second bump, so you might even get into asking, is this quartic in nature? But we're going to go with those three types: linear, exponential, and quadratic. So we're going to assume this is quadratic in some nature. So I'm going to do the same thing, stat, calc. I'm going to run a quad reg. Over here I'm going to go ahead and store that variable. Again, you don't need to store this variable in this equation in y1. I'm doing it for a good reason. But if you look here, do you see how r squared, they don't give us an r value, just give us an r squared value. Very similar, but it's 0.96. We're getting less accurate. This is not a perfect fit by any means. It's a good fit, but it's certainly not a perfect fit. Y equals, it says ax squared. Well, the a is negative 0.0079 x squared plus b 0.727x plus c, which is 13.76. So here's my equation. We have a decent r value. Let's look at what the graph looks like when it's plotted with the data. Is it a perfect fit? No, but it is a good representation of the data. It follows, and I can see that it's clearly trending back downward. Real quickly, if I went ahead and ran, like let's say that I thought this was linear. If I ran a linear regression, look at the R value. It's only 0.63. That's a low value. This is not an accurate representation. If I chose a different one, let's say I went with exponential, the other one that we've been using a lot of, has an R value of 0.6. Again, not a good representation. I thought for a second, this is a secondary thing, but I thought for a minute it might be quartic. It has like a double bump in it, and that would make me think of a fourth degree. If I did that, we got to arrow down to find the r value. The r squared value is actually really high. So this is not part of the problem. We're done, but I'm intrigued. So I'm going to look, and I'm going to run that quart regression. I'm going to store my equation in y2 so I can compare the two graphs. Now when I graph it, there's that graph, and oh, I didn't store it in y2. Darn it. I'll have to go back. Stat, calc, quart, variable, function. Let's go ahead and just store it in y1. We'll just overwrite the other. Alright. Now when I graph it, it does have that turn. It looks almost like this might be a better fit. Now, in the r squared value, we saw that it was a better fit, statistically speaking. That's a really interesting idea, is what is the best fit? And it looks like this is actually a better fit. Now, in the test, in the homework that you're doing, it's going to be linear, exponential, and quadratic. Those are the types that you're going to be dealing with. But this is the kind of problem that we try to solve all the time in modeling data. What is the best fit? How do we best represent the data? I hope that gets you through the homework and answers some questions. Good luck, and we'll see you in class.